Okay, so now what if I have n dots? What are we going to say about the total number of these connecting line segments?
Well,
what can we say?
You're going to have n line segments on the outside.
All right.
That like the perimeter of it.
Okay, there's n on the outside.
Well, and you have to connect them up on the inside. Well, last time, if we counted systematically, if we just started with one point and then connected all the lines going off of it, we would get one number of a factorial.
Well, how many? This is a very interesting thing. Let's say we start here and drew all the line segments.
It would be n minus 1.
Why?
Because you're not counting this point.
Okay, so this has
And
n minus 1 coming out of every dot.
You could do n minus 1 times n.
Okay.
But you'd have to divide by 2 because, again, you overcount everything.
Ah, interesting. N minus 1 times n over 2. How would we normally say this?
Well, we would. What do you mean normally?
Have you ever seen this expression before? Sorry, that was a silly way of phrasing my question. Have you ever seen this expression n times n minus 1 over 2 before?
Well, that's like the side. I think that's like one of our sides of a polygon. We did something with that. Seems familiar, but
n times n minus 1 over 2. Ever seen that before?
I think. I've seen it, but I can't place it.
Okay, that's fine. All right, so we found the total number of lines. We look at one vertex, and when there's n minus 1 coming out of it, and there's n of them, and then the same problem is we've double counted every single vertex, so we have to divide by 2. So a triangle, for example, when n equals 3, has 3 times 2 divided by 2.
That would be 6 divided by 2 is 3.
So if I connect all the points in a triangle, do I get 3?
Yeah, because it doesn't have any diagonals.
Okay. And what about a pentagon?
Well,
Pentagon,
We just found the pentagon had 10.
You'd have 5 times 4 over 2, which
20
which works.
Okay. Now, what about a 10-sided, a decagon?
Well,
how many does that
That
have?
would be 45.
45. Wow.
Wow.
So you can do it right away with this geometric counting argument. But now, here's the problem that was actually in the book that we were looking at.
Yep.
Counting the diagonals, which means we're not going to count the ones on the outside. The diagonals connect a vertex with a vertex that's not right next to it.
Well,
Okay, so let's do that for part C.
yeah.